Alright, so this is section 5.6, and in this section we're going to get into what is actually my favorite topic or favorite rule that we get to use, and that's when we have an indeterminate form and we get to use what's called L'Hopital's rule. Okay, and so let's just look at some examples of what an indeterminate form is. So indeterminate form is to do with limits. Indeterminate, I misspelled that. Let me see if I can. Okay. Indeterminate forms. Indeterminate forms are when we say, like, okay, we're going to let the limit of x as it approaches a number c. Then this function f of x over g of x is equal to 0 over 0 or infinity over infinity. Okay, you have seen indeterminate forms in like chapter 1 and maybe chapter 3. Chapter 1 definitely, but of what an indeterminate form is and how to use it with algebra, or how you solve these using algebraic methods. And let's look at an example of that. So let's say that, and this is for chapters 1 and 3 methods. So let's say that we have the limit as x approaches 4 of this function 3 times x minus 4 over x squared minus 16. Okay, if I were to just plug 4 into this directly, I get 0 over 0, right? 4 minus 4 is 0, so 3 times 0 is 0. 4 squared minus 16 is 16 minus 16 is 0 over 0. All right, so from chapter 1 and 3, how you would solve this is you would say, well, the limit as x approaches 4 of 3 times x minus 4, you would have to recognize that x squared minus 16 is a difference of squares. So that's x plus 4, x minus 4. Well, x minus 4 and x minus 4 divide out, so you would say that the limit as x approaches 4 of 3 over x plus 4. Then you would invoke the limit and you would say, well, that's 3 over 4 plus 4, which is 3 over 8. Okay, so it took some algebra reasoning, and this is not a bad one to try to do, but we now have a simpler way of doing it, and that is called L'Hopital's rule. Okay, L'Hopital's rule is by far my favorite rule from calculus, or at least Calc 1, Calc 2. And so what L'Hopital's rule says, which is not L'Hospital, just in case anybody was wondering, but it's L'Hopital's rule, says that when we have a limit that's in an indeterminate form, then we can say that the limit as x approaches c of f of x over g of x is equal to the limit as x approaches c of the derivative of the top function over the derivative of the bottom function. Okay, so what I can do is just take the derivative of the top and the derivative of the bottom until eventually a limit will spit out. Okay, so let's look at that same example. So let's say that the limit as x approaches 4 of 3 times x minus 4 over x squared minus 16. So now using L'Hopital's rule, I'm going to just take the derivative of the top and the derivative of the bottom. Okay, so I take the derivative of the top and I get, so I have 3x minus 12, so the derivative of that is 3. The derivative of the bottom is 2x. Now I can invoke my limit and say, well, that's 3 over 2 times 4, which is 3 over 8, which, as you can see, is the same answer that we got when we did the algebra steps. But now all I had to do is take a derivative. Okay. From a time standpoint, maybe in this example, it's not that significant of a difference. But let's look at one that maybe using L'Hopital's rule really makes a difference. All right. So let's say that I want to look at, so I have the limit as x approaches infinity of e to the x squared over 1 minus x cubed. Okay. Well, if I were to just plug infinity into that, I would get infinity over negative infinity, which is an indeterminate form, okay? It's not -1, right? It's just an indeterminate form because I don't know what infinity is. I just know it's a huge, huge number, right? But I can't just do, basic math with infinity. All right, so then L'Hopital's rule says that I'll take the derivative of the top. So we have e to the x squared 1 minus x cubed. Okay, so I'm going to take the derivative of the top, and using the chain rule, I find that the derivative of the top is 2x times e to the x squared, right? Because the derivative of e to the x squared is e to the x squared times the derivative of the power, which derivative of x squared is 2x, over the derivative of the bottom is 1 minus x cubed, which is negative 3x squared. Okay. For simplistic purposes here, before I mention that, let me say this. Still, if I were to plug infinity in, I'm still going to get positive infinity over negative infinity. So I have to do L'Hopital's rule again. Okay. So there are times that you may have to do L'Hopital's rule 3, 4, 5 times before you find an answer. But just check it each time you do the derivative and just see if you still are getting some kind of infinity over infinity, and you can keep going. Okay, you can keep going until you have constants, and then that will just tell you your answer. But we want to solve it, of course, as quickly and as efficiently as possible. All right, so I'm going to go ahead and divide out this x. So I really have the limit as x approaches infinity of 2e to the x squared over negative 3x. Okay, if I plug this in, I'm still getting infinity over negative infinity. So I am still not completely satisfied with my answer. So I'm going to take the derivative again and say, well, as x approaches infinity, and so I have 2, so I would do the derivative again, which would lead me with 4x, because I brought the 2 down as the chain rule, e to the x squared over negative 3. Okay. Now, if I were to plug infinity in, I have infinity divided by a negative, so I invoke my limit, and I find that it's just negative infinity. And that's a perfectly reasonable answer. Okay, so answers can be 0, 1, 2, infinity, negative infinity, but what we can't have is things like 0 over 0, or infinity over infinity, or anything like that. Okay, and so this actually concludes section 5.6. L'Hopital's rule is super useful. Indeterminate forms and finding those limits very quickly. But this does conclude section 5.6. Your homework just consists of doing these type questions a few times. One thing I'll mention, that the homework does ask you to do to show methods from section or chapter 1 and 3. Don't feel that you have to do that for me. Okay, so you see it's in an indeterminate form, apply L'Hopital's rule, and we will be good to go. So if you do have any questions, please feel free to email me, and have a great rest of your day.